So, how do you teach an AI to do something really complex, like put together furniture or follow a multi step recipe? It's a huge challenge for sure. These kinds of tasks need more than just simple trial and error, they need some serious long term planning. Today, we're going to dive into some absolutely fascinating research that tackles this exact problem by, well, bridging two very different kinds of AI minds. Okay, so in the world of AI, you've kind of got these two rival approaches. On one side, you have what we'll call the creative explorer. This is all about deep reinforcement learning. Basically, this AI learns kind of like we do when we play a new video game. You try stuff, you fail, you learn, and you slowly get better. It's awesome at adapting to new things. But man, can it be slow and inefficient. Then on the other side, you have the master architect. This is your classic planner. Give it a perfect, detailed blueprint, and it's an absolute genius. It will follow that plan to the letter. But here's the catch. Without that perfect plan, it's totally lost. It just freezes. And this isn't just an abstract computer science problem, right? This is about the real world. We want robots that can actually do these complex jobs in our factories, in our homes, maybe helping with cooking or building things. But as we just saw, neither of our AI minds is really up to the task by itself. So what do? How do you get them to work together? So let's get a little more specific here. Let's talk about the complex task problem. Why exactly are these long-term tasks so incredibly hard for AI? And why do both of our minds just fall flat when they try to handle it alone? I love this analogy from the paper. Think of it as the IKEA problem. We've all been there, right? You're surrounded by 100 little pieces, the instructions are kind of confusing, and you only get that feeling of accomplishment and reward at the very end when you have a finished bookshelf. There's no little prize for putting the first two pieces together correctly. And that huge delay before the payoff, that's what makes it so tough for an AI to learn. The technical name for this is a sparse-reward task. Imagine trying to learn how to play chess, but the only feedback you ever get is you won or you lost after the entire 50-move game is over. How would you ever figure out which of your early moves were good and which were terrible? It'd take forever. Well, that's exactly the challenge these AIs are up against. So in this world of sparse rewards, our creative explorer just gets hopelessly lost. It's wandering around, trying random things, and never getting that crucial little nudge of feedback to tell it, hey, you're on the right track. Meanwhile, our master architect is just stuck on the starting line. Why? Because it doesn't have that perfect pre-written instruction manual it needs to even begin. So, how do we get out of this mess? Well, this is where the new research really shines. The whole goal is to bridge these two worlds. It's all about uniting the creative, adaptable explorer with the brilliant strategic architect. And the solution they came up with is just so clever. Instead of making the AI figure everything out from scratch, which we know doesn't work, they give it a head start. They just let it watch an expert do the task correctly a few times. Then, the special induction module looks at those examples, figures out the high-level plan, and creates a knowledge base. Think of it like a cheat sheet that it then hands to our explorer to guide its learning. So, at its heart, this is a whole new kind of partnership. It boils down to three key things. First, the system just watches an expert. Second, and this is the magic part, it doesn't just blindly copy what it sees. It automatically figures out the underlying rules and pinpoints the most critical steps. And third, it gives that knowledge to the explorer, not as a rigid script, but as a flexible, high-level guide. But how in the world does it actually do that? I mean, how does a system watch a few videos and somehow pull out the secret recipe for success? Let's pop the hood and see how this thing actually works. The key to this whole thing is a concept the researchers call a critical action. Now, this isn't just any old movement. It's an essential step, one that actually makes progress towards the goal. And every critical action has two sides. Preconditions, that's the stuff you need before you can do it, and effects, that's the stuff you get after you do it. So the system follows this really clear four-step process. First, it just collects the demonstrations. Then it starts looking for links, connecting the dots between certain actions and the effects they have. Step 3, it turns those links into actual symbolic rules, like, okay, if I have wood and I'm at a workbench, then I can make a stick. Finally, it bundles all those rules up into these high-level plans, or critical action schema. Here's a perfect example from a Minecraft-like world to make this concrete. To make a stick, an agent might have to walk around, turn, maybe avoid some stuff, but the system is smart enough to learn that the only things that really matter, the critical actions, are picking up wood and then using the workbench. Everything else, that's just low-level noise that our trial-and-error explorer can figure out on its own. But hang on,
That brings up a really important question, right? In a long demonstration with tons of actions, how does the AI know for sure that it was the pickup action that caused wood to suddenly appear in its inventory? How does it pinpoint that exact cause and effect?
The answer is so cool. It's not magic, it's math. The system uses a technique to calculate the mutual information between every single action and every possible change it sees. And this heat map shows you the result. The darker the square, the stronger the statistical link. You can literally see it finding the strong connection between the action pickup and the effect get wood. It's an incredibly elegant way to find the signal and all that noise.
So the theory is beautiful, it sounds great on paper, but does this hybrid mind actually work in practice? Well, the researchers put it head-to-head against a whole bunch of other advanced AI methods to find out. And to put it simply, the results are pretty dramatic.
Just take a look at this chart. This shows how it performed on a really tough task called 8 switches that requires a long, perfect sequence of actions. See that line labeled hours that just shoots right up to 100% success? That's the new method. Now look at all those other lines flatlined on the bottom. Those are 7 other state-of-the-art AIs. They didn't just struggle, they completely failed. This isn't just a small improvement. This is the difference between solving the problem and not even getting started.
And what's really amazing is that it's not just a one-trick pony. This table shows how well it can generalize what it learns. On the original, easy task, it performs about the same as a standard AI. No big deal. But look what happens when you make things harder. You add more steps, you throw in distracting objects, you even change the rules of the game. The standard AI's performance just collapses, dropping all the way to 0 in one case. But the hybrid AI, it just keeps working, maintaining a super high success rate. It's not just memorizing, it's genuinely adapting.
Okay, so let's zoom out. What does all this mean for the future of AI? Why is this such a big deal?
The authors of the paper really hit the nail on the head. They say their work offers a holistic perspective. By integrating inductive learning, that's our explorer figuring things out from examples, with deductive learning, our architect using high-level rules, they've created a much more complete and powerful way for AI to tackle big problems.
And that's the bottom line. The crucial point is that we don't have to choose anymore. We don't have to pick between a creative AI that's kind of aimless and a strategic AI that's too rigid to function. By teaching them how to work together, by giving the explorer a map from the architect, we can finally create an AI that is both creative and strategic. And that leaves us with a really exciting final thought. This research proved that an AI can learn the hidden, unspoken rules for how to build things in a complicated virtual world just by watching. So the big question now is, what complex real-world problems, from discovering new drugs to managing global supply chains, will it learn to solve next?